Okay, hello everyone. So this session, basically what we're going to be doing, we're going to cover IPv4 addressing, um, focusing on subnetting, not every other type of subnetting, but variable length subnetting, subnet mask, variable length subnet mask. So I think from all the lessons that we've been doing, all the revision that we've been doing so far, we've learned that an IP address is made up of 32 bits. We've learned about the network portion and the host portion, and what is responsible for differentiating those portions is the subnet mask. And from there, we've learned, I think if you're given an IP address, we've learned how to identify the network ID. Then from the network ID, you can find the range of IP addresses that you can then assign to the devices in a given network. Then from there, I think with the range, we discussed the first, the last, and the broadcast IP address. We also looked at the inefficiencies that comes with, for example, if you choose to subnet your network from a perspective of the requirements of the networks, there are inefficiencies which comes with that. You might subnet four equal networks, each with 64 IP addresses, but from those four equal networks, you might have another one which requires only 4, 5 addresses. Then that leads to wastages of IP addresses. I think we passed through that. And that's the reason why we have variable length subnet mask, which subnets from a perspective of the requirements of the hosts in a network. What are the number of host addresses that are required in the network? Then if you get that, you can later on subnet, wasting the least amount of IP addresses. Right, so this is an example that we're going to do. We're going to subnet this one. Then we look at how do you then configure the network? How do you then, let's just say it's a design of very simple network. As you can see, we have four lines A, B, C, and D. Four local area networks. We also have a wide area network that is there, that link between the two routers. So basically, we have 5 networks that we have. So we're going to set up this network, design an IP addressing scheme, then configure it on packet tracer. Right, to now going to the subnetting part. The subnetting part is very much easy. Let me have another page. All right. So we have we have 50, 30, 22. So we have our requirements. We have A. Okay, we have 50, 30, 22. Those are the requirements that we have 7 and 2. Right? So these are the metrics that we have. 50 is A, B, C, D, E in that order. So this is A, B, C, D, E. So for our subnetting, what we're going to look at is what is the network ID. So the first one, we're going to find the network ID right here. Okay. So the network ID for this portion, then we're going to find the first IP address. We're going to find the last, and we're going to find the broadcast ID. Right, we're going to find the broadcast ID here. So this is our IP addressing scheme that we're going to design. Right, so now if we want to, let me add another page. Our network ID from the ISP was 192.168.10.0/24. And this is what we are going to subnet. We start our subnetting with the highest number of host addresses that is required by our networks, which is 50 host addresses for LAN A. Right? To accommodate 50 host addresses, how do we subnet our network to accommodate that? We look at our table, and I think from previous sessions, we discussed how to use this table. So to accommodate 50, we are looking at these numbers right here, 464, 26. I can make here 464, 26. So the first network that I get is 192 168, 10, 0, 26. I'm supposed to create 4 networks. Then our second network, 192.168.10 dot, we add the block size 6426. Then we have 64 plus 64, 128. Then we have 192. These are the 4 networks that I create from the first network, 4 subnets that I've created from the first network. Right, from the 4 subnets, you then take one of those. You can take any question. Please open the table one last time. Okay, there is the table. Maybe take a screenshot or something. It's very much easy to come up with it though. You can see my numbers are, my networks are taking up on 2, 4 times 2, 8, 16, 32, 64. Then these ones are taking up on 128 divided by 2, 64, 32, 16, 8, 4. Panapa, we are starting at 25, 26, 27, 28, 29, 30. It's very much easier to come up with this table. Right. Hoping, I think you've got what you wanted there. Right. So for the first network with 50 hosts, you can take any of these networks. Performer networks, you can take any. Now, when you are being assessed by my skills assessments, you see you will be asked probably to take the second network or to take the third network. So if you're asked to take the second network, it means you take this network to accommodate this set of IP addresses. If you take the first in an exam, then your IP addresses will not match. Your network might function, but if your IP addresses don't match, you won't score um, you won't score enough percentages which are required for the exam. So you need to be very careful. If you are the one designing the network, freestyling with the network, it's okay. You just take the first network IP, network ID, first subnet, and you address it to the number of hosts that you have. But when it comes to the exam skills assessments, you need to be very careful. What are they asking? Sometimes they say take the last network, meaning you have to take this one and leave the other 3. So for this one, we are going to take the first network. So the first network will accommodate these 50 hosts. And our network is 192.168.10.0/26. Now we go and translate this to our table. So this is 192.168.10.0/26. That's our network ID for the first network. And let's look at the network, all the network IDs first. I wanted to fill up the table. Let's look at all the network IDs first. Now we're going to 30. To accommodate 30 hosts, network B. How do we deal with that one? For 30 hosts, going to our table, to accommodate 30 hosts, now we are looking at these numbers. 832, 27. I come back here, 832, 832, 27. And which network are we applying this on? We take the second network. We've already used the first network. So we take the second network and we start subnetting it again. If we take the second network, we are left with these 2 networks right here. These 2 networks, it's always wise to say these are the networks that we can use for future use. If our network expands, scalability, we talked of scalability, I think, in the first chapters of CCNA. Your IP addressing scheme allows scalability because you have a couple of networks that you can use for future use. This is basically what it is. So if we take the second network, we want to subnet it again using our numbers 832.27. Our first network that we have will be identical to the parent network, which is 1064. The only difference will be the subnet mask. These 2 are not the same because of these numbers here. The network IDs might look the same, but if the subnet mask is not the same, they are totally 2 different networks. Right, so this is the first network. We're supposed to have 8 networks. Right, the second of these networks will be 64 plus this block size. So that is 96. Let's just look at the third one. This is 8, 128, slash 27, slash 27. Then they go up until you have 8 networks. If you do practice, you see you won't be able to get to 8 networks. And the reason why is because some of the IP addresses, host addresses, if I can say, they've been used in this network, not this one. They've been used in this network right here that we've assigned to the first subnet. Right. So for our 30 LAN B, 30 hosts, we take this one, the first one again. That becomes our network ID. Let's put it in our table. So it's 192.168.10.64/27. So I come back here, 192.168.10.64/27. That's it. We go to LAN C, 32, 22. If I go to the table, for 22 IP addresses, we are still stuck here, 832.27. So automatically, I can choose the next network with /27. So this one goes to 30, then the next network goes to 22, this one, with 96. There is no need for me to take a network and subnet it again because the requirements fit the number of IP addresses that host addresses that we're going to have in the network. So this automatically becomes for the network with the 22. That's 96. I come back here and I feel 168.10.96.27. In an exam, you should be doing the same thing. This is how you approach a question. With practice, of course, you can definitely skip some steps because you now know what you're doing. But the starting point is exactly what I'm doing here. Identifying the networks, listing them, then finding the range in the broadcast ID so that you get an idea of what IP addresses you can later assign to the devices in the network. Right, now we move to 7. Back to our table. To accommodate 7, we use this one. If we use this, the maximum number of usable addresses is 8 minus 2, which is 6. So we cannot use this one. So we use 16, 16, 28. I come here, 16, 16, 28. Which one do I take? 16, 16, 28. Oh, let me leave the networks that I had here. I think I'll need to use them at some point. Right, so 16, 16, 28. I'm going to take this one. This one has been used. This one has been used. I'm going to take 128. So I take 192.168, 10, 128. We're at 7, 27. We are 27. Yes. Now we use 16, 16, 28. 16, 16, 28. Right. So the first network is the same. It looks identical to the network above with the difference of the mask. And this mask becomes the same as this one. We are going to create 16 more networks. With the practice, you will never get those 16 networks because some of the IP addresses have been used. You are starting here with IP address 128 instead of 0. If you start with 0, you get 16 networks. But if you start with 128, you won't be able to get to 16 networks. Right, so this is the first network. The second network, we add 16. 128 plus 16, 144. 144 plus 16, 160. That's the third network. Right? Right. So we take this one for C with 7 IP addresses. So it's 192.168.128.28. So I come back to my 192.168.10.128/28. Right, done. Then lastly, the one with the two IP addresses. So we use this one, 64.4/30. So we're going to use 64.4/30. On which network? We take the following network, 192.168.10.144.28. Right, if we subnet this, the only difference will be that last number there. So this is the first network. after we're subnetting using these numbers. The second network plus 4, 148 plus 4, 152 slash 30 slash 30. We take this one and we use this for our two addresses. So it's now 144 slash 30. I come back to my table, 192, 168, 10, 144 slash 30. Now, what is happening? What is happening to all, for example, here we're supposed to create 64. Like I said, we won't be able to create 64. What happens to the rest of the networks that we have here? Because we've only used one here, future use. So as an administrator, those networks are set aside for future use. Let's say, for example, we've expanded our network. We have another network that requires that has its requirements needing two host addresses. Then you come and take this network without subnetting, without doing anything. Another network needed, you come and take this one. We also have unused networks that are here. You have another network which uses which needs I think 7 to 14. Is it 7 to 14? This is 4. So 4 to 14, is it? No, it's 8. 8, so this is 6, 7. 7 to 14. Exactly, 7 to 14. If you need another network which has requirements 7 to 14, then you can count permanent our creator because they can accommodate 7 to 14 host addresses. You take one, you take another, up until our exhaust S. So this is for future use as well. Tikadzoka even panap, pane two asinoshanda future use, then pane mango asinoshanda futi panap, the future use as well. But can all attempt a question, I think you won't put my future use networks into consideration. Right. Now we are done with subnetting yatopera. Takuenda pa finding the range. The first address panap will be .1 slash 26 panapa .65 slash 27. Here we have .97 slash 27. Then here we have .129 slash 28. Here we have .144 145 slash 30. Right, we'll go to the broadcast ID. That's the easiest one to look at. The broadcast ID. How do you find the broadcast ID? Right, you look at this network. It's much easier looking at from this perspective. So for the first network, this was the first network. First subnet that we subnetted. These two, you look at these two numbers, 0 and 64. This is the ID of the next network. -1, which is 63, is the broadcast ID of this network. If I'm looking at this network, I look at the next network. -1, 127. It means 127 is the broadcast of this network. And it goes on like that. So for the first network, the broadcast ID is .63. Automatically, this one becomes .62 slash 26. Then I go to 30. 30, here is our 30. We look at the next network. The next network, which had 2296 here, meaning our broadcast will be 95. Our broadcast will be .95. Then here we have .94 slash 26. For understanding where these numbers are coming from, I think during revision, we're doing binaries. We're working with 1 zeros, 1 zeros. For example, here, what does broadcast mean? It means all these numbers are ones. That's how you find the broadcast. Then what is the last address? It means after you have all your ones here, 1, 1, 1, 1, 1, 1, 2, 3, 4, okay, 5, with the last 0. This is the last IP address. So if you go back and practice, your numbers will definitely make sense. You know where they are coming from. At this point, we're at the point of no return. Takungoisa my numbers. Those who understand, get it. If you don't, you will have to ask. I want to say forget it, but we can't do that. You have to ask. So we go to 22. Looking at 22, we look at the next network, which is this one with 128. meaning our broadcast is 128 minus 1, 127.127. Here we have dot 126 slash 27. Right, we go to 7, 128, 28. 7, I think with 7 we're here. 1.143. Which one in it? Dot 143. Yes, 7. Okay. Yes, 7. We are looking at. Can I trust you? Broadcast yes, 7. Yes. Okay. Let's trust Sharon. Sharon said so. I'm not looking at anything. So it's that dot 143 broadcast. So for this one, dot 143, then it means dot 142 for the last address, 28. But the addresses, you always move with the subnet mask. In this case, the prefix length. Because if you don't highlight what the prefix length is, and you easily mistake these numbers right here, then everything will be for nothing. Because my subnet mask, they are very crucial in identifying my networks. So my numbers are no that's why I'm putting them together like that. Then for this one, we have the last one. So we are looking at here, we are looking at this one, 148. Then we are looking at 147 being our broadcast. So dot 147 is our broadcast. Then dot 146 slash 30 is our last address. Right, we are done with that. Now going to my configurations. Let me remove this. Right, we now go to packet tracer here. Tracer my networks here. So network at designer is right here. Sessions are two my routers IO. We're going to create four my networks IO, A, B, C, D. Tracer probably one or two pieces so that we can later on test for connectivity and all. Right. Is my packet tracer up? Right, there it is. Right. So two my routers. At this point, ndopa maufana otanga kudzidza and practice how to come up with my networks from scratch. Wega, it's very much possible and you can do it. All right. And do the switch hero. All right. So let me put switch. Let me put them four switches. On my network, that's not my angle. But let me put it there. Okay, router. I can use straight through. And the reason why I can use straight through is because of auto MDX. But under normal circumstances, I should be using crossover. But I can use that because now we have auto MDX. Right. Fast is 0. Let me put a Giga Ethernet here. 0, 1. Let me put a Giga Ethernet here. Another gig. Oh, impossible. All right, so they are our problems. Yeah. I can use this one here. Connecting two routers. Let me use a serial link DTE. I got a problem and I wanna what's it kwani ayo arpa on this PC. Right, we need to use a completely different router, or we can add. Right, I would do the sign is outside the scope. Let me add. Let me see. Turn more faster up. Connection in our group, right? Gig Ethernet ports, SFP, fiber, and shielded. Mangana. SFP 1000. No. Standard category, SFP, auto index. Let's try to use this one. Switch it off. Right. Zirikuitika apa. Can anyone guess kuti zvii zvirikuitika? Before not compatible. Can anyone guess kuti zvii zvirikuitika apa? Ane muono yekuti zvii zvirikuitika. What am I doing? Pane zvinhu zvaindanonjema ipapa. Okay, let me just explain it. Right. Muri kuona this router, we are supposed to have two networks. So ndikaisa two networks, I've used two interface. Then I'll need another interface connected to this router, making a total of three interfaces. But ndikatasa router red iri rine interface mangani? Rine maviri. Like if I do this, we only have these two interfaces, Giga Ethernet 000 and 001. So I was trying to add an expansion module, but a repo. So I want to add an expansion module. Let me see, or add this one. Not compatible as well. Let me change it. Let me change our router to an ringway. So for this one, how many do we have? CLI. Let me do this. This one also have two. Expansion modules. Let me switch it off. Giga Ethernet ports, industrial Ethernet, not this one. Giga Ethernet ports, even data fiber, man. Can we connect fiber to fiber? No. Solutions of fiber. Provides four switching ports. Right, let's use this one. All right, four switching ports. So this one is compatible. Right, add my ports up. So you can see instructions 4321. Right, some devices papa. That's where you should learn also as well. Kuti ndikati 4331 router. What are the characteristics of that router? In my ports mangani, does it have expansion modules? Which ones are compatible with which types of expansions that you have? So for this one, I think we have one with this one. You can see the extent that animal ports at one day. So we can now make our connections much easier. Although this is a simulation in real life networks, it's almost the same thing that also happens. So we're learning. You are learning as well, right? I wanted to put a serial link, but yet. Muruba there is ready now. So let's remove this one. Delete. 4321, okay, it's there. Kana urikuita practice uri wega. That's how you get to learn as well. Ukasaita wega, this kind of practices, you will never learn anything. Never learn anything. Physical. So we're adding this one. Switch it off. Design your own networks from scratch. Get stuck. Find solutions for that. Switch it on. So right, we're on it. Let's switch it on as well. Right, I think my network set are proper. Let's now connect this to this. Why am I radar? That shouldn't happen. Okay, it should happen. connect this to this. Let's say for connection there. Right, for my networks here to Apple. Let's have for my PCs now. I think I'll just put one PC in each network. 1, 2, 3, 4. Are you following? It is here. Estimating ka network akapabepa. Kukatiza na packet tracer. I didn't think of everything that I've done here. No, I didn't. Right. So network yedu yapo. We start nama configurations edu. So far, so good. Just a boy. Did you get what we just did there? I think the only tricky part in the kusama those expansion modules. This is a huge network. Hey, this is a huge network. But anyway, let's work with it. Right. Takwenda pa configurations edu now. I need someone in chat and tell that we are following. So far, so good. I would hate kunguvamba mune vanhu vasirumboziva kuti tiri kuenda nekupi zvii zviri kuitika. Anyone? Hello, Judith. Are we still there? Hello. Are we still following? We are following, saying good enough. Good enough. Right. So now takwenda kuno configure IP addresses from the IP addressing scheme that we created. So scheme yedu, there it is. Oh, this no. Voila, is here. Right. So recommended. My first IP addresses are recommendation. My first IP addresses they're used for my interfaces, which will be the default gateways to the network. Let me plug in. So it means my network LAN A, this will be the IP address of the interface. So this is LAN A. What's the is .1/26. It means IP address of this interface will be .1/26. This one. .1/26. This interface. Then this interface in LAN B is .6527. So this one will be .6527, right? Then LAN C in a 2297. Here we have .97/27. Then for 7, .129/28. .129/28. Then for these two, E, okay, it has a crossover here. So these two IP addresses, this one, to know one of the IP addresses that is up. Only two only. So 145 and 146. 145/30 and 146. So this one will be 145/30. This one will be 146/30. Tapets up. Then you will see mostly as well there a switch up. So there's a switch. Right, another switch. So I need to get the same design radiator. Another switch. Then a PC. Right. My PC is Edu. Let's start with my switch. My second IP address is to my SVI, switch visual interfaces. switch. Second, IP addresses. So it means in this network, .1 panapa taxa .2 26 panapa taxa .66 27, right? Panap 97 up, panel 98 27. Then for this one, switch visual interface .130/28 tapets. Then any other IP addresses within the range yakupia kuma PCs. So my PCs .2, I can give this one .10. Okay, let's just make it easy. .3, the third one, 66 panel, 67 panel, the 98, 99 on this PC, 130, 131 on this PC. So this is /28/27/27. This is /26. Right, need to get it up there. Now, chasara kungo configure shit. Right, I can see I have less than 1 minute. So join me in one more session to configure network ADS to a page, and then we look at what comes up next.